Welcome to Study Loop.
Let's make a substitution to rewrite this integrand as a rational function. Since I see this hyperbolic cosine in the numerator, that suggests that I should take u to be hyperbolic sine. Then du is hyperbolic cosine. So we can rewrite this integral on top. There should be a dt there. Then we just write that as du. That takes care of the hyperbolic cosine in the dt because of this equation over here. And then on the bottom, that's just u squared plus u to the fourth. So let's write that as, let's maybe write this as 1 over, we can pull out a u squared, and then we get u squared plus 1 left over. Then pull out that du. Now we can do partial fraction decomposition here. So first we should check that this factor right here is non-reducible. So we have to look at the discriminant, b squared minus 4ac. Here, b is the coefficient in front of the u term, u to the first power. There is no such term here, so that means b is 0. 4 is there, and then a is the number that's in front of the u squared. Here it's just 1. And c is also the constant, which is 1. This is a negative number. That tells us that the quadratic will not factor. So here, on the other hand, this is u times u. So this is what the author calls case 2. This is when you have a repeated linear factor. So for the u squared, we get a over u, b over u squared. But then for the u squared plus 1, using what the author calls case 3, we have cu plus d over u squared plus 1. So let's just go ahead and keep the integral there. And then these two terms that we'll circle and blue are equal. All we did was the partial fraction decomposition. And now we actually want to go ahead and see what a, b, c, and d are. So looking at these circled expressions here, let's just multiply both of them by this denominator on the left. So the left-hand side, I just get left over a 1. And then I have a, u squared plus 1. And I also should have a u there in the a. So let me put a u out here. Another u. B, u squared plus 1. And then cu plus d, and then times u squared. Let's go ahead and multiply this out. Au cubed, au, bu squared, b, cu cubed, du squared. And finally, let's combine like terms. So let me pull out a u cubed, a plus c, pull out a u squared, b plus d, pull out a u, we're just left with the a, and then the constant term left over is a b. So looking at the left-hand side, there's no u cubed, there's no u squared, and there's no u. That tells us that a plus c, b plus d, and a are all 0. So there we also get that c is 0 using the first equation. B plus d equals 0. And then the last term on the right-hand side is the constant. That must equal the constant term on the left. That means b is 1. And then using this equation here, along with b equals 1, we get d equals negative 1. So we found all 4 values, a, b, c, and d. Let's just plug them into this previous integral, then start integrating. But I'm running out of room, so I'll need a new page here. So let's go ahead and plug in those values. We have 1 over u squared, and then minus 1 over u squared plus 1 du. Now we can go ahead and just use the power rule for the first integral. This is just negative 1 over u. And for the second one, this is very common in a rule. This is just arctan of u. And let me make a comment about that. If you forgot that fact, then you could go ahead and do a trig sub here. U equals tan theta should work. So go ahead and do that if you must. The last step here is to just use the definition of u. So the real definition of u, not from the trig sub. So here in the previous page, we chose u to be hyperbolic sine. So now we just replace. And then we have minus arctan, and then u, which is again sine h, hyperbolic sine, plus our constant c of integration, and that's our final answer.